we finally worked our way to the engine phase of this project. The plan is to strip it down to the long block, clean everything up, reassemble, and then check the engine's vitals on the test stand. While we have it in pieces, the air cooling system is going to get a lot of attention. This flashy yellow paint job may have been impressive in its day, but the aftermarket housing is a bad sign. We'll keep it, but there's no rules here. We can modify and fabricate as much as necessary to ensure the cooling air makes it to all the areas where it is so badly needed. Undoubtedly, we'll find things that need attention, but with that one exception, we're going to try and keep this simple. The objective has always been to get the bus back on the road first and then assess the need for any further repairs. Besides, Dweezil is sitting right over there and expects some attention after this Project Vandemic thing is complete. The two should make a great pair and will likely lead to bigger engine projects than the one we're in now. We really can't pass up an excuse to dive into something like that. These little engines are fascinating. Compared to other automotive engines, these are closer to what you might find in a lawnmower. They're simple on the surface, but a close study reveals precision engineering that was ahead of its day. A day that happened in the earlier part of last century. Maybe that helps explain the duality of its reputation for reliability and high maintenance requirements. And maybe that's the lesson here. To get the reward, you have to do the work, and there's no guarantees. Today we'll get a feel for the engine's condition by stripping it down to the long block and inspecting a few parts. This exciting process often reveals issues that change the course of a project. And that's okay, because the stated goal is just a summary of our intentions. The journey is whatever actually happens. The best projects change us in some way and account for a part of our lives that we didn't postpone and will never replace. So we'll keep at it until we're done, and when we get there, we'll hop in and go for a ride. For a while there, I thought things were really going downhill. I stripped this one. That was really where it started. It's not bad stripped, but it's stripped enough. Then this one broke. That may not turn out very well either, but that's all right. We're gonna try it. I'm pretty sure this one rotated a little bit. Then I got the heat to it and the coil to it, which I like that stuff. That one came off, and this one already had a step stud in it, and that's what came out. But I just thought for sure that when it was rotating that it was in the act of stripping. But it looks all right. The real thing that concerned me was this. This to me looked a whole lot like oil. You can see down here that there's a replacement push rod tube. This thing spit out a push rod long time ago. I was kind of going on about how with my buddy VW Jawbreaker, I was kind of going on about how I really didn't want to pull the heads because I kind of know what that leads up to. Or, you know, you split the case needs to be a line board, and you need a crank, and you need this, and I need this one to run. That's, you know, I'm gonna do what I have to, but I'd like this one to run. And he goes, well, you sure it's oil and not just old gas? When I ran the engine to get it in here, it ran really, really bad. After I'd pulled the engine, I was looking at the carb, and I noticed that when I pull the throttle, that the squirt out of the little tube from the accelerator pump was shooting sideways, and it was just clogged up a little bit. And so I unclogged it and squirted some more gas, and it worked just fine. There was still some fuel in the bowl. But I did that a few times, and all of it ran down this way and into that port. And so that new gas sat in there and dissolved the old gas and gave me this brown, oily consistency that smells like gas. So we're okay. I thought maybe there was a bad valve guide or a crack in the head or something awful like that. And it just so happens that it's, you know, it's on the intake runner where all this stuff happened, right? So I got a little bit fooled by some coincidental data. That was pretty cool. Thanks to VW Jawbreaker for being the brains in this story. There's some things, but no catastrophes. So I'm gonna finish tearing this down. I'm almost as deep as I'm gonna go, and then start the cleanup process. been messing around with this engine, just kind of cleaning it and making little fixes, like made this stud here and got that installed. For the most part, I've just been getting acclimated with how I want to do this. And it's taken a lot of self-control to not go any further than this. I've done that enough times to know that once you get that deep, there's a long list of things that you might as well do while you're there. And I'm pretty sure I would find some of those things. For example, the oil pressure issue is probably because the bearings are worn out. There's other things you can do, and I'm actually going to try some of them, but really to solve the issue, I think that's just where you find yourself. Is it just becomes an actual rebuild of the engine and all that wonderful stuff, because that's it's a fun process. It's expensive, not what I'm in for right now. So I'm going to use some self-control here and not go any further into the engine than what we have. Also spent some time getting a broken off screw from the cooling tin out of here, which was pretty cool. I used the method where you spot weld or tack weld on the top of whatever remains. Had to be real careful not to hit the aluminum. I only wanted to hit the mild steel down there, and then tack, 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 build it up and use that to unscrew it. And the first time or two or nine, this is just going to bust off, but eventually the heat has shocked everything so much that it starts to loosen up. Right now, heat is playing a big role here, and what you eventually get is a stud out of there. And if you're lucky enough and skilled enough with the welding, it all lands on the top of the stud and doesn't chew up the surrounding material very much. And I don't know, I got it here a little bit, but I think I did pretty good. I'm going to play a few games with the oil pump. This I think is an original one. It's got the VW stamping on the back of it, and it's probably seen its better days, but I'm going to take the one that I have and do what I can with it. And there's a few things that we can do here. I want to make sure that this has a tight fit with the case, otherwise this is going to leak, right? It'll just squirt right back into the case. So that's something to check. I'm going to round off some of the hard edges here on that inlet port and this outlet port. Nothing too huge, but just something to allow the oil to flow a little bit more smooth. I'm going to also make sure that the gears are all the way to the top of the housing, so they're just flush there, and any clearance necessary to allow these things to spin freely will be provided by the gasket. There's some pretty deep scrapes in this that allow oil to bypass, right? So we're losing some pressure in some of this drama here. And so all I'll do is take both of these, put them on a surface plate thingy, and sand them down until they're absolutely flat. So first, let's take a couple of measurements. We want to know how much space is there between the very end of these teeth and the wall of the pump. 4 thousandths is our limit. Hopefully it's kind of snug, if not smaller than that. We're going to take that measurement a couple of places down here, and we'll do the same for the drive gear. Got drive gear, driven gear. But we'll take the same kinds of measurements up here and see where we are. Hopefully we're about 4 thousandths or smaller. Here's my 4 thousandths feeler gauge. That won't even get in there. That's a good sign. And I can get it up here. It's not quite as snug as I'd like it to be, but it is snug. We've had more crud go up this way than down here, or more wear anyway. Let's see what that bottom one checks out to be. I'm going to go down to 0.003 here. There we are. Okay, so we're at 0.003 down here, 0.004 up here. I think that's right at the wear limit. That's as loose as we want it to be. So we'll go with that and be thankful that it's kind of sort of usable. I'm going to get in here with my Dremel and radius out this edge. I read all of this in How to Hot Rod VW Engines. Pretty good book, all right? It's like the Tom Wilson book. You kind of want to have it. But I'm going to round off this. I'm going to bring this all the way out to that edge. I'm going to try not to go past it, but to get rid of that turn. I'll smooth this down here just a little bit. You can see it doesn't need much, but I'm just gonna basically get rid of this 90-degree edge here and round these things off. We'll do a similar thing over here. All right, so this is the outlet hole. So I'll take this edge off as well. Round this out to here, round this out maybe into over here and to the flat part. I don't know why, but I'm advised to leave this alone entirely, and I don't really have any reason to get down there, but there's something apparently to watch out for. Now, if I was doing full flow, I'd be focusing on the outlet on the full flow cover that goes across all of this. Just hit it with the Dremel. I'll do a little touch up here. So we just radiused that edge as best we could here. It's actually pretty smooth. I'm pleased with that bit. That bit did a good job of this. This is the outlet. Did similar work over here. So just a lot smoother of a turn for the oil to take. I wanted to keep this edge. All right, so I went right up to it, but I didn't scallop out that edge at all. Similar deal over here. I wanted to keep this edge. I rounded out all the way up to it. There was a little ledge here before. So cool, all right. I think that's what I can do within reason for an old worn out pump. Let's sand this thing now. Some pretty good scratches on the bottom here. I'm gonna see if I can smooth that out. There's a ding here that was creating a little bit of daylight in between the cover and this surface, so that would explain some pressure loss. You can see it's getting hit first. With all of this attention being spent on the oiling system vis-a-vis the oil pump, I'm going to take some measurements of the relief and control valves for this case and compare them to measurements we'll be taking of the bores that these pistons go into. So we'll take outside diameter of these guys and compare it to the inside diameter of the holes that they go in to see how much oil clearance there may be in between the pistons and the cylinder bores themselves. This is another place that our oil pressure goes. It's a small piece, but it's a piece that I have access to right now. So if I discover a really huge problem, now it's going to be the time to fix it, maybe with some new pistons or something. First thing, I'm going to measure this guy. This is the oil pressure relief piston. This is the one closest to the oil pump that all of the cases have, the single and dual pressure relief cases. This one is 0.6271. I'm estimating 10 thousandths of an inch. I'm going to write all this stuff down. The relief outside diameter is 0.6271. This is the control valve. This one, if I understand it correctly, was added for high pressure situations when the engine was spinning really fast. This one's a little bigger. Maybe it was supposed to be the same size, but he's a little big. I see 0.628. That's flat right there. So I'm going to say 0.628 inches, and that is the control. So let's measure these guys. I don't have a very good relationship with these little snap gauges because I'm not confident with them yet. You loosen this and the little spring-loaded dealies push out against the walls of the bore that you're trying to measor, and you tighten it down. And this is where the banjo music starts to play and hijinks ensue, because you got to get it out of there without squeezing these things in at all and messing up your measurement. So it's easy to end up with a measurement that is smaller than the thing that you were trying to measure. The other problem is that you got to measure it with something else. There's no way to know what that is, right? So we're going to put it into the micrometer once we get our measurement and measure it from that. So there's an extra step. There's another opportunity to mess this up. Here is the pressure relief. There's a bore going this way, and I don't want to get this stuck in that hole. So I'm going to turn it this way, loosen my little thingy thing, get all the way down into the sleeve, try and keep it straight up and down here. And now that I've set it, I've tightened my little thingy, I'm going to turn sideways to try and make it a little skinnier to get it out of there. Okay, I don't think I've caught on anything on the way, so let's measure this. Throw this in the micrometer. I'm going to back it up a little bit. We're expecting this to be bigger, right? Because that piston has to fit down inside it. Okay, I have 0.631. Let's just go with 0.631 flat. For the relief valve, which is 0.631 flat, and that is a difference of a lot. Almost 4 thousandths. So the clearance is 0.0039 thousandths. That's pretty much 4 thousandths of an inch. That's kind of big. That's not too good. I may look at another piston for this. Yeah, we'll measure one up and see if it fits any better. Same thing, there's a bore going this way, so I'm going to go down sideways like this. Okay, I'm going to tighten up my little thingy thing, go sideways to try and make it skinnier. All right, let's go measure that. That is 0.6273. 0.6273. That's much better. 0.627. No. Don't go crazy, Brent. This is a 5 down here. I'm above that. So this is 0.6323. Estimating the 3 thousandths. 0.6323 thousandths. And that is terrible. 0.0053 thousandths, right? Nope. 4. My math is not that great. Even worse is what we're seeing there. Let's go find some new pistons to see if that helps us at all. Here are some aftermarket pistons. The flaw in this plan is the wear is in that soft magnesium. I guess it could be sleeved and all kinds of things that no one ever does. So unless this was manufactured a little bit large, we're probably out of luck and are just gonna have to eat it. Let's take a measurement of the relief piston. This is tiny. Take a look at this. That is 0.6182 or so. So let's compare. About 9 thousandths smaller than this one, meaning the clearance would be about 9 thousandths more. That's crazy. How many times have we said this, right? We're better off with worn out parts than with brand new ones. Just while we're doing it, let's check the other one. This is 0.623-ish, which is 5 thousandths smaller than the old worn out one. Okay, never mind. We'll run what we brung. Okay, so that's what we'll use. Kind of blown away by that. Just to make sure that we're all on the same page. The engine is upside down right now, so I am being very careful. This is just the kind of thing that I'd mess up. I'm very, very careful to remember that the inlet is over here and the outlet is over here. I do not want to put this in upside down. So the outlet is the small hole. That's the one that goes over on this side. And the inlet on this engine is the big hole. That's going to go over here. Just want to put it in this way. All right. Also need to line up the drive gear and the tang that will come out of the back here with the end of the cam that you can see inside there. So yep, this is gonna line it up correctly. So now I need to tap this thing in. The engine work for Project Vandemic is just getting started. The cooling tin is a project of its own, so subscribe to Haptic Garage and be a part of the repairs, modifications, and whatever else it takes to get this thing on the road. In the meantime, check out one of these videos and I'll see you in the next one.